everybody. I hope you guys are having a wonderful day today. So our lesson today is about base N numeration systems. So the number system that we use is base 10, but we're going to talk about how it will work if you have other bases instead. So in our last lesson, we talked about several different numeration systems that have been used in the past. And our current numeration system that we use is the Hindu-Arabic numerals. So the way that Hindu-Arabic numerals work is you have 10 different digits or 10 symbols that are listed here. And we use these 10 symbols and write them in specific orders to communicate the different numbers that we use in our modern number system. So one of the characteristics of the Hindu-Arabic system is that we group our numbers by tens. So we go like 1, 2, 3, 4, 5, 6, 7, 8, 9. And then once we get to the 10, we change place values and we write it as 1, 0. Then, you go 11, 12, 13, all the way up to 20, and then 30, 40, 50, 60, 70, 80, 90. And then once you get up to 99, then you move on to the next place value. And then once you get up to 999, then you go to 1,000 and so on. So one of the things that can be really useful for helping students understand how our modern day numeral system works is to use base 10 blocks. So a base 10 block set looks kind of like this. And basically you have all of these little unit blocks. And then if you have 10 unit blocks stuck together, it creates a rod or like a 10 rod. And then if you stick 10 of these rods together, it makes a 100 plate. And if you stick 10 100 plates together, it makes 1,000 block. And you can buy like physical blocks, or you can also use applets on your iPad. So if you're ever working like one-on-one with students, and especially if they're like a kinesthetic learner, using the physical blocks can be really helpful. But if you're teaching an entire class, that can sometimes be a classroom management nightmare. So I really like using an iPad and just projecting the image up on the screen. But you can do it basically however it works in your classroom with your classroom management style. So base 10 blocks are really useful, and you can also make this a little bit more abstract by using a chip abacus. So a chip abacus is basically when you have like a poster or a piece of paper or something that's blocked off into a ones column, a tens column, and a hundreds column, and you could also do a thousands column if you want to. And then you use different chips to represent how many blocks you have. So I would recommend starting off with the base 10 blocks, but as you get into bigger numbers that are more clunky to actually use the blocks for because there's just a lot of them, you can simplify it by using different colors of chips to represent the blocks. So they're kind of related, but the base 10 blocks, I would recommend starting with those when you're teaching your students because they physically show the different sizes of the different amounts. Like the ones are just going to be little blocks, but the tens will be big blocks and the hundreds even bigger and so on. Versus with the chip abacus, your little chips are all going to be the same size. So you should probably start by using the base 10 blocks, and then you can abstract it to be a chip abacus. So this is something that I would really recommend using whenever you're introducing a new concept, because it's going to help the students conceptually understand how it works instead of just memorizing facts. So one of the things that is often taught to help students understand how the base 10 number system works is to write numbers in expanded form. So expanded form is basically when you take the number in each place value and you write it out and show what those place values represent. So if you have 82,604, you would basically say, okay, well, I'm going to have 8 times 10,000 because I have an 8 in the 10,000 spot. Then the 2 in the 1,000 spot is written as 2 times 1,000. The 6 in the 100 spot is written as 6 times 100. The 0 in the 10 spot is 0 times 10. And the 4 in the 1 spot is written just as 4. And sometimes, depending on your textbook, this can also be written as 80,000 plus 2,000 plus 600 plus 0 plus 4, or sometimes they don't even write the 0, it's just like this. But writing out numbers in this way can really help students understand what the number actually means. And it can also help them when you're looking at the names of the different numbers. So when you're writing out the names of numbers, you know, we have our standard base digits, 0, 1 through 9. And then we have 10. And these two numbers are actually kind of like weird. Like they don't really follow a specific pattern. So after 10, we have 11 and then 12. And then after that, it does follow a pattern because 13 and 14 and 15 and 16 and so on are basically like 3 plus 10 or 4 plus 10. And you can kind of see that in the way the word is written. 14 is 4 and 10. And then once you get up to 20, then the pattern becomes even more consistent because you have 21, 22, 23, and so on and so forth. And 35 is 3 10s and 5 1s and so on, all the way up until you get to 100. And then you just continue adding on place value. So the way that you would write a number like this is you would say, I have 1,000 300s and then 74. And that's the way you would write a number like this. Or if you get a really big number like this one, you would have 23,100. And when you get to really, really big numbers, the place values are kind of grouped into groups of 3. So if you had a huge number like this one, you basically have your 3 like base place values, like your 1s, 10s, and 100s. And then after that, you have your thousands and your millions, your billions, and your trillions. So the way that you would read this number is basically in groups of 3. So I would say I have 744 trillion, 210 billion, 898 million, 564,798. And that's how you would describe a large place value like this. And I believe usually in elementary school, you don't really get any higher than millions. But sometimes kids will be curious and they'll wonder what comes after millions. And so you can Google this if your students ever ask you this. But there is a specific pattern to how it goes. So you have millions, and then you have billions, and trillions, and quadrillions, and quintillions, and sextillions, and septillions. And if you notice, the root words in these place values basically match the numbers. So like bi means 2, tri means 3, quad means 4, quin means 5, sextillion is 6, septillion is 7, octillion is 8. And basically they follow this root word pattern up until the decillions, because deca means 10, like decimals is when you split things up into 10. And then after that, there's more patterns after that. So like you have undecillion or duodecillion or tridecillion, or however you say that word. I don't even know how to say that. But that's kind of how the place values build on themselves. So if you ever have a curious student that's like, what comes after this? You can always look it up and see what the names of the place values are after that. So this is how our number system works. And our number system is based on the number 10, because 10 ones becomes a 10, 10 tens becomes 100, 10 hundreds becomes 1,000, and so on and so forth. But there are also other number systems that are based on other numbers. So I'm going to show you a little clip, well, it's actually kind of a longer clip, of how I introduced this concept to my little sister. So my little sister is 9 years old, and we like to do math adventures where we just play with different mathematical ideas. And this is a shortened version of a math adventure that she and I did together. So the original clip was like an hour and a half. But she is 9 years old and gets distracted easily. So I clipped the distracted parts out. And this will give you a really good introduction to how a number system that's based on another number other than 10 would work. So I hope you guys enjoy it. And then at the end, I'll come back and kind of summarize the important concepts from this video. All right. Okay, so I want you to pretend like we're way, way back when numbers were first being invented by humans. Okay? So why do you think it would be helpful for humans to have numbers? Like what would be a situation where they might need to use numbers to be able to count things?
Maybe if they wanted to do like inches or something. Hi, they probably didn't even have inches back then.
Probably not. Probably not before numbers. So like imagine maybe like if we were like a caveman or something and we had a whole big flock of sheep, right? If we had a whole bunch of sheep and we wanted to make sure that we kept all of our sheep safe every night by bringing them into our cave, we would probably want to know how many sheep there were so that we don't accidentally miss one and it like gets left outside and eaten by wolves or something, right? Like that would be an important
Or
reason
freezes
to be
to
able.
death.
Yeah, that's true. Sheep, depending on how cold it is, they might freeze to death too, right? So counting or knowing how many sheep we have would be really important if you were a caveman, right? And so we might say like, okay, well, every time a sheep walks into our cave, we're going to count it on our fingers. And we might not even have words for it. We might just say, I have this many sheep. Now I have this many sheep in the cave. Now I have this many and 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 this many. But then once I run out of fingers, if I still have more sheep, I have a problem, right? Because it's like, what? I don't have any more fingers to represent it. So maybe I could say, hey, Belinda, you hold up a finger that represents this many sheep. Then I could keep counting the sheep. And I could say I have this many, 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 and this many. And then what do we do?
I held up another finger
Perfect. And then we
to
keep on
represent
counting.
20.
Exactly, right? And so let's say that you had like 4 fingers up. So like we count all of our sheep and you have 4 fingers up and I have this many fingers up. How many sheep do we have?
We would have 47.
Perfect, right? We'd have 47 sheep. And so we'd say, okay, well, that's the number of sheep we have. And we just make sure that every night we get that many sheep into our cave, right? And then maybe like if more sheep are born, then we'll like have a bigger number. And if some of the sheep die, or if we eat our sheep because we're hungry, then some of them will go down. But we could use that to count our sheep, right?
Yeah, like subtraction or adding. Any of
Exactly.
that. And you wouldn't be able to do math without numbers. Unless
Exactly,
you did it
right?
without unless you did it with the alphabet.
Mm-hmm.
I wonder what one would be. Maybe one would be A, and then two would be B.
Yeah, because it doesn't really matter what symbols we use to represent the numbers, right? What really matters is the amount that's there. Okay, so let me share my screen really quick. All right, so, if we imagine being these cavemen with our sheep, right? Like it works for a little while to just show on our fingers how much we have, right? But if we wanted to write a letter to one of our family members that lives a long ways away and write a letter that describes how much sheep we have, we wouldn't want to have to like send our fingers to our family, right? And it would also be kind of difficult to have to like draw all of the fingers and explain what it means. So we started using symbols to represent numbers. So rather than having 47 be Belinda holding up 4 fingers and me holding up 7 fingers, we learned to write our numbers with symbols like this, right? So what I was wondering is what do you think would happen if we were aliens and rather than having 10 fingers, if we only had 6 fingers? So we only had 3 fingers on each hand. Do you think that aliens would count differently if they only had six
Maybe
fingers instead of having 10 fingers?
probably because they wouldn't even have a 10 or a 9 or a 7. Oh wait, no, or
Mm-hmm.
an 8 or a 7. They would only have
Right,
6.
right. So, and aliens might also have different symbols to represent them, right? Like an alien might, like if you said, oh, I have this many sheep, an alien might not say that that's the number 4. They might use another symbol, right?
Like a square.
Yeah, that's a great idea. Let's have it be a square. And that makes a lot of sense because you have 4 sides on a square, right? So what kind of symbol do you think we should use to represent the number 3? Like if the alien has 3 sheep.
A triangle.
Okay, could have a triangle. What type of symbol should we use for the number 2?
That's a tough one.
Yeah.
A
So like
circle?
a triangle has like 3 points and a square has 4 points. So maybe if we want to represent the number 2, maybe we should have 2
A
points.
line.
A line?
A line.
Okay. Awesome. So let's have a line represent the number 2. And then what should we have represent the number 1?
A dot?
Okay. So we'll have a dot. And I'm just going to write what these are in our language. So we have the number 1, the number 2, the number 3, the number 4. And then what do you want to do to represent the number 5?
What shape has 5 dots?
So there's a
I know a
pentagon.
pentagon could be for 6.
Actually, it would be a hexagon for a 6. A pentagon has 5.
Oh, so a pentagon. Yeah, a pentagon could be the 4th thing.
The 5 for the number 5?
I mean the 5.
Okay. So we could use a pentagon, but pentagons are kind of hard to draw. So what if we actually do a star? Because a star has 5 points as well. And it's a little bit faster to draw.
Oh, yeah.
Pentagon, it's kind of hard to draw it. So are you okay if we use a star to represent it instead?
Yeah.
Okay, awesome.
And besides, it's more pretty.
Exactly.
And it doesn't look the same as, wait, are we only going to have six shapes?
That's a good question. Okay, so let's look at our number system. So our number system, we go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the number 10 doesn't actually have its own new symbol, right? The number 10 is 1, 10, and 0, 1s, right? So like that represents when our fingers get full. So for our alien numbers, if we're counting our sheep and I say I have dot number of sheep, and then I have line number of sheep, then I have triangle number of sheep, square number of sheep, star number of sheep, I think that we actually shouldn't have a new symbol for this one because this is when my fingers are full. So how would we write 6 in alien language? Because this is when my fingers are full, so you hold up a finger. So you hold up a finger that represents having this many sheep. So how do you think we should write that?
Wait, I know how we should do a 0.
Okay. What if we just keep it as a 0? Because it's like...
Yeah, it doesn't have any line. It doesn't have any dots.
Exactly.
Any points.
Exactly.
So it can be a circle.
Okay. So how would I write our number 6? So if we have this many sheep, so I have, my fingers are all full and you hold up a finger, how would we write that in our alien language?
Wait, so you have how many fingers?
So I have this many sheep, but since my fingers are full, I'm going to not hold them up and you're going to hold up one finger. How would we write that in alien?
We would do dot circle.
Okay. So that's basically saying that you're holding up one finger or dot fingers and I'm holding up 0 fingers. Right?
Mm-hmm.
Okay. So what
Well,
if
you're
I
holding
have,
up circle fingers.
yes, circle fingers. Okay. So if we have dot circle, and that represents the number 6, what number would represent the number 7?
Um, dot dot line.
Dot line. Okay, so you're holding up one finger or dot fingers, and I'm holding up line fingers. So how many sheep is that? Is that 7 sheep?
Yeah,
How
that
many
is
sheep
7
does
sheep.
your finger represent in like our English language?
Mine represents 6.
And how much do my fingers represent?
Yours represents 2.
So if we had dot line, would that be 7 sheep?
What?
So if you have dot number of fingers holding up, you said that's 6, right? Because each one of your fingers represents 6 sheep. And if I'm holding up 2 fingers, does that represent 7?
Mm-hmm.
So 6 plus
It
2 equals
does.
7?
Uh-huh.
No, it doesn't. 6 plus 2 equals 8.
Oh.
Okay, so I don't think it's dot line. Let's change our answer a little bit. So let's represent the number 7. So I'll go ahead and count the sheep, and I'm going to count them in English words. So we have 1, 2, 3, 4, 5, 6. So now you hold up a line, or you hold up a finger.
Oh wait,
And
it would
then,
be be dot dot.
perfect. Yep. So you'd have dot dot. Then
Or
how
should
would
we
I,
call
oh, go ahead.
or do you think we should call like the dots that like since it goes up on 6, do you think we should
Mhm.
call it dotty
Oh yeah, that
instead of
would make
dot?
sense. Because kind of like in our number system, like when you go up to 20 or 30 or 40, we could have like this place value be like the T place value. So this could be dotty, and then like this could be dotty dot. You want
Or
to do
that could
that?
be dotty. That could be dotty circle.
Or, but like, because when we say 20, we don't say 20, 0. We just say 20,
Oh
right?
yeah.
And so it would be faster to say it if we just called it dotty. Okay, so we have dotty, which is in alien language is equivalent to our number 6. Then we have dotty dot, which is equivalent to the number 7. What would the number 8 look like in this new alien language?
It would be dotty line.
Okay, dotty line. So if we've got that, then what would the number 9 look like?
It would be dotty triangle.
Okay. And then if we had our number 10, what would that look like in alien language?
It would be dotty square.
Okay. And then our number 11, what would that look like?
It would be dotty square.
I thought you said 10 was dotty square.
Oh yeah. It would be dotty star. Oh wait.
Okay. And
I
then
just
what would the
realized
next number
something.
be? Oh, what did you realize?
Oh, it would be line dot. No, liney dot. Liney dot. That kind of
Okay,
sounds like some sort of wine.
so let's do it with our fingers.
Liney
So
dot.
if we have 11 sheep, what do our fingers look like? How many fingers are you holding up?
Wait,
Okay, and then if we
wait, no,
have,
two. No, wait. No. Let's see here.
so the number 11, we're looking at the number 11. How many fingers do you have up?
I would have 2.
Are you sure? Because if you had 2 fingers up, remember each of your fingers represents my fingers being full. So if my fingers were full 2 times, would that be 11?
Oh, I would only be one, but one away from
Right.
being two.
Yep, because at 11, I would have star fingers up and you would have dot fingers up, right?
Uh-huh.
Now, if we
No,
count one
dotty
more sheet,
fingers up.
oh yes,
It'd have dotty fingers up.
yes, because yours represents the T's, right? Okay, so if we have star, if I have star and you have dot, then if I count
Dotty.
dotty, sorry. If I count one more sheet, then my fingers are now full. So I'm going to put my fingers down and you're holding up how much?
I'm holding up liney dot.
Just line T, because I'm not holding up any fingers. Because
Oh yeah,
remember, my
liney.
place value is just going to be at 0. So this would
Oh
actually
wait,
be
no,
line
liney.
T. Yep, this would
It's
be line
liney.
T. Yep.
Line T is kind of like 90.
Uh-huh. Kind of. Except it equals 12 in alien language. Okay, so what would come after line T? Like what would be equal to our number 13?
It would be line, liney, liney line.
Okay, so let's show
Oh wait,
that
no,
on our
liney
finger.
dot.
Yes.
Liney dot.
Yep. Okay, then what would the next one be?
Then it would be a liney triangle.
Triangle. So if I'm holding up 3 and you're holding up 2, how much do your 2 fingers represent?
It represents 12 for us.
Okay, so you have 12, and if I have 3 for triangle, that it would actually be 15. So I think 15, I'll write this next. 15 is line T triangle. Because if I'm holding up triangle fingers,
Oh, it would be a liney line.
yep, line T line, good job. Okay, what would come after that? What's the number 16 in alien language?
It would be liney square.
Okay, and then the number 17?
17 would be, let's see, line star. Liney
Line T.
star.
Okay, what would 18
Line
be?
T star. Oh, that would be triangle, circle.
Mm-hmm. What do you want to call that?
Trinkle. Trinkle?
What if we called it triti?
Trite.
Then it's a nice short
Okay,
word.
trite.
Triti.
Okay, trite.
Okay, so this will be triti. So alien triti equals our human 18. What if instead of like counting by like ones, you know, like so we have like 18, 19, because I think we all know, like we can kind of see the pattern that this is going to be triti dot, right? And then 20 is going to be triti line. Like we can keep on going with that. So what is the next T going to be?
It's going to be square T.
Okay, so we have square T. And what is square T equal to in human numbers?
Honestly, I'm not
Count
used
on your
to this
fingers.
kind of.
So we know that on your fingers, so you hold up your fingers. If we have tri-T, so hold up on your fingers, Belinda. If you have tri-T, then if you add one more T to that, so tri-T is 18. Oh, you don't have 4 fingers as an alien. You only have 3. So you're going to have to use your other hand. Yes, but not on the same hand. Okay, so we have tri-T. So hold up tri-T. Okay, now hold up square T with your other hand. You don't have that many fingers. Okay, square T. So you have square T fingers up. How much does that represent? So like the tri-T is 18, right? And then the one more finger you held up, how much does that represent?
19, 20, 21, 22, 23, 24. It's 24.
Okay, perfect. So square T is equal to our 24. Then we'd have square T dot, square T line, square T triangle, square T square, like we'd have all of these things. And then what would our next T be?
It would be starry. Yeah, starry.
Star T. Okay, awesome. And what does star T equal?
Okay, let's see. So, 25, 26, 27, 28, 29, 30. So, I'm lost.
That's okay. You got it. It is 30. Right? Because like
30 is what?
if square T equals 24 and star T is one more T more than that, like 24 plus 6, because each T is a 6.
Yeah.
That would be 30, right? Okay.
Yeah.
What comes after star T?
Dot T, circle, circle.
Okay, so dot, circle, circle. Like
Wait,
that.
but we should call it something else.
Yeah,
because it's not dot T anymore.
Right.
Maybe dot dread?
Oh yeah, that would work. Kind of like 100 if we called it dot dread.
Yeah.
Okay. So what human number does dot dread equal?
Oh. See, so let's count up 10.
Well, it's not 10, it's 6. So dot dread is when your fingers get full. And we would ask another alien to hold up their fingers.
1, 2, 3, 4, 5, 6. Wait, no.
Okay.
36. That's 36. Dot
Yep.
tread equals 36.
Yep.
So
exactly.
if you're dot tread, then you're actually only 36.
Yep, exactly. Okay. Cool. Okay, cool. So we've basically invented a new number system, right? And you could count infinitely long with this, right? Because you could have dot dread, square T line or something. And that would represent a number. But then you could even go even bigger and you could have
line dread.
Yep. How much would line dread be? How much would line dread be? If we had line dread, how much would that be?
Yeah, I don't really want to do that all. Quite an involved process.
So maybe it might help us if we visualized it a little bit. You want to visualize it?
What does visualize mean?
Okay, so I'm gonna, you know how we have our base 10 blocks that we do in our math adventures together? So this one makes it so you can change it so that it's base 6 instead of base 10. So here we have this is our T because you have 6. And then this is a dread. Does that make sense?
Yeah.
Okay.
That's dot dread.
Yep, this is dot dread. What would this be? I'm going to delete this one. What would this be?
2 dot dread.
line.
Oh, wait, no, that's line dread.
Yep, this would be line dread, right? And so how much is line dread in human numbers?
Let's see. 1, 2, 3, 4, 5, 6, 7, 9.
So
10,
maybe
11.
let's start with what we already learned. So you learned that this is 36, right? That
Mm-hmm.
dot
Oh,
dread is
we can
36.
do 36 plus 36.
Yep, what would that be?
36. See, so that would be 60, and then we add sixes together, and that would be 12,
Mm-hmm.
and we have 60,
Mm-hmm.
and so we do 72.
Perfect. Yep, let's go back to that. Okay, so dot dread you just found out is 72. So let's play a little game. Let's pretend that I'm an alien and I'm telling you how many, I don't know, how many apples I want to buy from you. Okay, because I'm an alien and
What?
we don't have. So I'm an alien and I'm telling you that I want to buy some apples from you because there's no apples on my planet, but I think they're delicious. And I tell you that I want square dread, line T, triangle apples from you. And you as a human, you say, I don't know how much that is, but let's see if we can figure it out. So if it's square dread, line T triangle, how much is that?
So why don't we get 4 of those 100 square dread thingies,
Mm-hmm.
and then
So we have
wait, what was the whole number?
square dread, line T triangle.
Okay, so line T is 2 tenths.
So we have square dreads, line T's, and then the last part of the number was a triangle. So we had square dread, line T triangle.
So we need 3. We need 3 yellows.
Okay, perfect. I don't know why it's not selecting them. There we go. Okay, awesome. So how can we figure out how big this number is?
Can you go back to that other thing?
Yep.
I think I might have the answer.
Okay.
So, we to get the square dread answer, we could add up 72 plus 72.
Okay. Yep. Because line dread, which was 2 of them, was 72. Okay. So how much is that?
That would be what's 7 plus 7? Okay, so 7 plus 7 is 14.
Mm-hmm.
And then 2 plus 2 is 4.
Mm-hmm.
So we would get 144 from that. And then line D is just adds on. Wait, how much is line D?
Let's go back and look. Oh no, it erased it. Dang it. Line T is
What?
this much.
It's 12. Line T is 12.
Perfect. Okay. So that would be 12. Whoops, that's under that line is 12. Okay. And then what else would be
Triangle is 3.
Okay,
so if
awesome.
we add 3 to that, it would be like if we add 3 to 12, then it would be 15.
Mm-hmm.
And can you erase those 2 and go to
The 72?
into a 15?
Oh, you want me to write those
Yeah.
into a 15. Okay, so that makes 15.
Uh-huh.
Okay.
Yeah, and then we would do repeated addition with 1, 4, 4, and 15. 144.
Mm-hmm. And what would that equal?
Can you stack them on top of each other? Better.
Sure. Like that?
Yeah.
Okay.
I don't know why, but that would be 1, of course, because it's 1.
Mm-hmm.
And then that would be 5.
Mm-hmm.
And then that would be 9.
Perfect. So how many apples do they
So you
want?
think 159.
Okay, awesome. So they want 159 apples. And let's say that we want to tell them how much that's going to cost. Okay, so let's say that we want to have $85. And we're going to charge them $85, but we need to convert it into their language so they know how much we want from them. So how could we write
So
85 in their language?
5 is it's a star,
Okay,
and 80, I have no idea
okay.
what that
So
is.
let's maybe go back to our blocks over here. So how big or how much is this block?
That's a dread.
It's a dread. And in our language, how much is it?
I forgot.
36.
Oh yeah, it's 36.
Because you have 6 plus 6 plus
Yeah.
6 plus 6, like 6 times, right?
Yeah.
Okay, so this would be 36. Then what if we had 2 of them? How much would that be?
That would be line dread.
Line dread, how much is it in English?
I keep forgetting these numbers. Can we go back?
Well, I'll just tell you. So tell me what the addition problem would be, and I'll tell you what the answer is. So if we have 36
it,
and another 36,
it would be 36 plus 36.
which is 72. Okay, and we
Yeah,
want to
so
charge them 85.
80. Yeah.
Yeah, so do we want to charge them another dread? Would that be
No.
80? No, no more than that. Okay. What
We
do
need
we want to
to
charge them?
wait. Let's see. So what would it be? I
So
have
this
no
is
idea what 80 is.
so this would be 72. And you said we don't want to charge them another one of these. Why don't we want to charge them another one of these?
Because I was thinking that we would do it in their
Because that would be too big, right? Because if you had 72 plus another 36, that would be like 106 or 108, I mean, right? Which is way
Yeah.
bigger than what we want to charge. So we're not going to charge them that. Do we want to charge them one of these though?
Wait, so how much was that? It was
The 2?
72?
Yep, 72.
Yeah, so 72, and how much should we want to charge them? 80.
85.
Oh yeah, but we already got like um the 5 part figured out.
But maybe not though, because like it might combine with some of them.
Oh yeah. So we have 85, and that is
Well,
72.
this is 72. Not with this.
Yeah, so
This green one doesn't count as a 72. So what I'm asking is, do we want to charge a green one?
yeah.
Okay, and how much is that charging? Like if we told them this amount, like if we said, oh, it's
72. Let's see. So if it's 72, then 72 plus 6 is 8? No, 6. No, 8. Yeah, 8. It would be
78.
78.
Okay,
So,
then would
but
we
we
want to
want to
charge
charge
them
them.
another one?
Wait, so it's 8. Yes, I think so.
Okay,
Or
because
maybe not.
if you do
How much would that
78,
be?
so you said this much was 78. And if we did this much more, 78 plus 6 would be 84.
80. Oh, and then just add a 1.
Perfect. Okay, so what would be the name of the number we would tell the aliens that we want in exchange for the apples that they bought?
It would be line D. No, line. Wait. How did you say that? 101
Dread?
for line?
Dread?
Oh
Line
yeah,
dread?
line dread.
Mm-hmm.
And line T dot.
Okay. So you're saying we would write it as
Line
line
dread.
dread?
Line
Line.
line T dot. Line
Okay.
dread line T dot.
Awesome. We have now invented an alien numbering system. So if you want to, we can do addition and multiplication and subtraction with alien numbers if you want to do another math adventure, but this is where we're going to end this one. Before we do that though, I think it would be good if you practiced counting in alien numbers. So do you think you could count from, like, write down on a piece of paper all the numbers from dot to dot sand? And we'll have dot sand be the thousands.
Dot sand.
Yeah,
Okay.
so like up to this number. Oh, well, if it was a 6, what this would be.
Yeah.
So count all the way from dot up to dot sand and write it out kind of like how we did this. You know, so like we have like our English numbers here and our alien numbers here.
Okay.
Okay, so now that you've watched this little clip where Belinda explored these alien numbers, I want you guys to look at this pattern of another made-up number system that I just randomly created. And I want you to see if you can figure out what the next numbers would be in this pattern. So pause this video and see if you can figure out what our numbers from 27 to 35 would equal in this number system. Okay, so as you were working through this, you may have noticed that this number system is based on the number 3. So the number system that Belinda was exploring was base 6 because the aliens had 6 fingers. And this number system is base 3. So usually we actually don't write numbers with different symbols when we're working in other bases, just because it's like, we kind of like already know the symbols like 1, 2, 3, and so on. And so coming up with new symbols like trite or square or dotty or, you know, all of those numbers that Belinda came up with, it can almost be just as confusing to try to come up with the symbols. And so when we work in other bases, rather than coming up with new symbols, we're just going to use the regular symbols that we're already used to. But to designate that it's not our regular base 10 system and it's a different base, we're then going to use a subscript that says what the base is. So basically, if we were looking at this base 3 numeral in that number system that you explored in that last activity, what this would mean is that we have a 2 in the ones column, a 2 in the threes column, because if you are doing base 3, 3 ones is a 3. And then if you have 3 threes, that's going to be the nines column. Then 3 nines will be the 27s column. And then basically with each place value, you just multiply by 3. And you can write other base numerals in expanded form, similarly to how we write out base 10 expanded form. So if I wrote this number out in expanded form, I could say, well, I have a 2 in my ones column, and you can represent this with 3 to the 0 if you want, because any number to the 0 power equals 1. Then I have a 2 in the threes column, a 1 in my nines column, which could be represented by 3 squared, a 1 in my 27s column, and a 2 in my 81s column, and so on. And this can be really helpful when you're trying to figure out what a base 3 number is in base 10. And you can also visualize it with the blocks, kind of like I did with Belinda. And I'll give you guys the link to that applet that I used so that you can play around with the blocks if that's helpful for you. And when you go into the applet, this button right here is the one that changes the size of what base you're working in. So if you want to use that applet to help you out, you're welcome to, because it can be very helpful to visualize the different bases as you're working with them. And you can have any base. So we could have 1, 3, 2, 6, base 8. And what that means is that you have a 6 in the ones column, a 2 in the 8s column, because if you have 8 ones combined together, that's an 8. Then if you have 8 8s combined together, you're going to have the 64s column, or the 8 squared column. Then if you have 8 of those combined together, you'll have the 512s column, which is 8 cubed. And basically each place value just increases by multiples of 8. And so that's the way that other base systems work. And on your homework, you're going to practice using these other base numerals. So again, you're welcome to use those blocks on the applet if you would like to. And I hope that you enjoyed watching Belinda explore her alien numbers. So I hope you guys have a good day. And if you have any questions on your homework, just let me know.